Now, after that, we have run our code. It might take a minute or so. So let me explain each of these codes so you can understand why we have used these code here with the prime distribution and the cross validation equal to 5 and number of iterations equal to 20. To start with the prime distribution, as you know that the random seed that we set it to 42 to ensure the reducibility of the results. To start here, we have chosen the randomized search CV to find the best combination of the logistic regression model and the prime distribution. This is where you specify the hyperparameter grid. When we chose the regression grid, it contains the value for the C. The C is the regularization strength. And if you recall, we also use the solver, which is equal to linear. The cross validation is set to 5, which is it's the number of folds for the cross validation. So we chose 5-fold cross validation, means the data will be split into 5 parts, and the model will be trained and validated 5 times, each time using a different subset of the data as the validation set. As you recall here that we have distributed our data into 5 different versions of the training data and evaluated to ensure that also it's evaluated into 5 different versions of the test data set. The n iterary here we have set it to 20. This is a number of random combination of hyperparameters to try. In this case, it will randomly sample 20 different combination of C and solver from the grid that we created here earlier. The verbose is equal to true. This option prints the progress during the search, so you can see how the search is progressing. And then we ended up by fitting the model using our training data. So the fit method trains the logistic regression model with the best hyperparameter chosen by the randomized search CV, because it mainly used to find the best, let's say, configuration of the model, and it will evaluate each combination using the cross validation and keep track of the results, as we could see. So if you click here, you could see the cross validation, and these are the number of iterators that we have set for the logistic regression model. As you can see that here it has evaluated each of these folds and iterators, and it has returned to us the best logistic regression hyperparameters. Let's now find the best hyperparameter found by the randomized search CV for the logistic regression model. To do that, we'll type finding the best by the randomized search CV. Let's first use the print function. We'll type best parameters for the logistic regression model. To do that, let's present the RS log regression dot best params. Go. Now let's run this code and see what are the best type parameters that it has found. So as you could see, for the solver, it has chosen the lib linear, and for the C value, it has found 0.2. So the code rslog.reg best params is typically used in the context of model search using randomized search CV or grid search CV in scikit-learn, where you perform a randomized or grid search to find the best hyperparameter in the model. So the best params here, as we could see, it stores the set of hyperparameters that were produced the best model performance during the search. So as I mentioned, the best hyperparameter in our case, this shows the set of hyperparameters that perform the best of the cross-validation, while the best cross-validation score, this gives you the score of accuracy, for example, if you have achieved the best hyperparameter during the cross-validation. To explain what are the best cross-validation score, let's add some code to find the best cross validation score achieved during the search. To do that, we'll also print the best cross-validation score, best score that has to use the rs log and call the method which is best score. Let's again run this now and see so this is for the best hyperparameters for the logistic regression model. Let's see now the best cross-validation score achieved. So the best validation score has achieved is 0.83. So again, as I mentioned, the best cross-validation score, this gives you the score of accuracy, for example, achieved with the best hyperparameters during the cross-validation process that we have implemented. If you recall here that we have around 5 cross-validation. So the best model or the best, let's say, combination, it has returned to us with 0.83. Now let's try to validate our score also on the test set. So we'll start by evaluation on the test data set. Once we have found the best hyperparameters, as you could see, is front of us, which is the solver for the linear, and the C is equal to 0.23, and the best validation score is equal to 0.83. Let's now start evaluate the middle performance on the test data, which is the data that wasn't seen during the training, to get the sense of how the model generalizes to new data. To do that, let's start by typing evaluate the tuned logistic regression model but this time on the test dataset. To do that, we just can, put our test scores is equal to the RS log regression score. This time we'll use the X tests and the Y test datasets. Let's now print the results. Score that has to equal to let's set our values. Okay, test score. Let's also multiply that with 100% so we can get percentage here. Let's run this code. So that is quite good. So our test set accuracy score is 88.52. Now that we have tuned our logistic regression model using randomized search CV, and the result was not too big difference than our baseline, if you recall, with the results of 88.52%. Let's recall our previous scores for the for the logistic regression. Our initial scores was around 88.5. So after that, we have tuned our model using randomized search CV. We couldn't see a real improvement after tuning the model. Or let's say the variance was not too big, compared to the original scores. So that's all for how we can, tune our model or logistic regression model using the randomized search CV to find the best parameters to apply to the model. Next, we are going to talk about the randomized or random forest classifier, and we'll also use the randomized search CV to see whether this method could, improve our third model, the random forest classifier model. So let's start by tuning the the random forest classifier model using the same randomized search CV method.